So another related rates question, tracking a fast jet. A spectator at an air show is trying to follow the flight of a jet. The jet follows a straight path in front of an observer at 540 miles per hour. At its closest approach, the jet passes 600 feet in front of the person. Find the maximum rate of change of the angle between the spectator's line of sight and a line perpendicular to the flight path as the jet flies by. So let's draw a diagram to see what this looks like. So first of all, the spectator is at the origin here. And the spectator is looking up at a jet. So we have the flight path of a jet. So the jet is following this flight path. And this is at 540 miles per hour. So this is our x-axis. So this is going to be our x. So our change in x in respect to time is going to be 140 miles per hour. Now, it also says here that the jet passes in front of the person at 600 feet. So this is, the height is 600 feet. So this is y. Y is going to be 600 feet. So the angle that's formed, we don't know. What else do we know? So the maximum rate of change, so we need to find d theta in respect to time. So that's d theta over dt. We don't know. And spectator, observer, spectator. So that means the same thing. That's this person by here. So let's have a look. The jet follows a straight path. So the rate of change is not going to be of the height. So dy by dt is not changing. This is going to be 0. So let's try and have a look what we need to do. Well, first of all, we have two different units. So we have miles per hour and we have feet. So we need to change dx by dt into feet. So what do we have? Dx by dt is 540 miles for 1 hour. Now, to be able to change this, we need to know the conversion rate. So to change miles into 1 mile is equal to 5 to 80 feet. So we're going to have 5 to 80 feet divided by 1 mile. Now, when they are opposite like this, we can simplify. So now we haven't got miles, but we need to find the rate of change of the angle, which means we have degrees, minutes, and seconds. So we need to change our hour into seconds. So 1 hour is equivalent to, so there's 60 minutes in an hour and there's 60 seconds in a minute. So 60 times 60 is 3,600 seconds. So now our hours will cancel. So now we just need to simplify this, and we can do that in a calculator. So we'll have 792 feet per second. So we have changed this to 792 feet per second. So we've got all the other information. So we need the rate of change of our angle, but we need the equation. So we want the equation to find the angle. So what do we know about our angle? Well, if we think about trig, we know that a right angle. So we have x is opposite and we have y which is adjacent. So tan of our angle is opposite of adjacent, which should be x over y. So this is our equation. So we have tangent of theta is x over y. Now, to differentiate this, because we have x divided by y, we are going to use the quotient rule. Now, you could put y to the minus 1 and use the chain rule if you prefer. So I'm going to use the quotient rule. So tangent of theta, this is going to be secant squared theta, but we have to use implicit differentiation. So this is d theta by dt. And then this is, we're going to have, so dx by dt multiplied by y minus, and then we've got x multiplied by, so dy dt, and then this is all going to be divided by y squared. So substitute in what we know. So we don't know our angle. Dx by dt we know in the question because we're given it, and we've changed it to 792 feet. Y we know because we have this as 600 feet, so this is multiplied by 600, minus x. Now we don't know x, but our change in height, this is 0. So when we multiply them, x is gone, so this is going to be 600 squared. So secant squared theta d theta by dt. If we simplify, this is 33 over 25, which is approximately 1.32. Now I'm going to divide both sides by secant squared theta. So this will cancel. So the rate of change of our angle, 1.32, and it's multiplied by 1 over secant squared theta. Now, secant squared theta is the same as cosine. This is going to be the same as cosine. So I can rewrite this as 1.32 multiplied by cosine squared theta, cosine. And what do we know about cosine? Well, the maximum value for cosine, we've got -1 and positive 1. So the maximum is 1, the minimum is -1. So if we substitute in this here, so -1 squared or 1 squared is just going to be 1. So we'll have d theta by dt is 1.32. We've changed this to seconds and our angle is going to be in radians. So this is radians per second. So the angle is positive, so it's going to be increasing at a rate of 1.32 radians per second.